Hi everyone. So today's paper is about a prompting strategy called least to most. This method is built upon a chain of thought prompting strategy. So before moving forward, let's just have a look what these different strategies are. So in prompt so in prompting, what happens is the language model is frozen, so there is no training, and it is given a prompt. So what prompt is? It's an input where we provide some examples like question one, question two, answer two. So these are some examples how it has to be solved. The task has to be solved, and then there is a new question. The language model will take the help of these prompts and also leverage its pre-training to answer to this new question. Okay, so we'll see, like, so these three are prompting strategies, so we'll see what these are. Let's go to the appendix. Okay, so standard, so let's take a task. This task is about last letter concatenation experiments. So what happens here, that we take the last letter of the question, of the words in each question. Like, think the last word is K, here it is E, and the final answer is KE. Here is GN, so that's the answer. So in standard prompting, there is no other text, there's just simple question answers, and it's provided with a new question, and language model is gonna give you the answer. In change of thought prompting, there will be question and there will be answer, but there's a good explanation about how they arrived at that answer. For example, the last letter of think is K, and the last letter of machine is E, and when you concatenate it, you're going to land up to KE. So the think machine outputs KE. So this is about like how human thinks and how different like series of thoughts lands us up to the answer. So here you can see that there are different question answers, and they are not related because think machine is different and learning, they are completely different. Okay, in least to most prompting, what happens is we have this question and we have this answer, and the next question is related to the previous answer. So once we have the answer for think and machine, which is KE, then we can solve a little bit more complex problem which is based on the previous question. So think machine learning can be solved by breaking this into think machine and learning. So think machine outputs KE and the last letter of learning is G, so concatenating these two is gonna give you the KEG. Again, they have another example where this is a complex problem and they have this sub problem which is solved first, and then they use the output of it to solve the next one. So this is how the least to most prompting. Here the samples are related, in the chain of thought they are not. Okay, so let's go back to the abstract. So what they're saying is we propose a novel prompting strategy called least to prompting that enables large language models to perform multi-step reasoning tasks. So least to most prompting first reduces a complex problem into a list of subproblems and then sequentially solve the subproblems. They are experimenting on, so what they're doing here is reducing the complex problem into a list of subproblems, and sequentially they will solve the problems one by one. And so that's the idea of the paper. And the experiments they are doing, the data sets they are using are on symbolic manipulation, composition generalization, and numerical reasoning. They are using GPT-3. So why did they improved on chain of thought? There has to be some limitation of it, right? So what was the limitation? So the key limitation of chain of thought prompting is that it often performs poorly on tasks that require generalization from easy to difficult problems. What it means is, so why they chose all these data sets? Because the commonality among these tasks is that the test examples are from a very different distribution than the training examples, which significantly challenges machine learning methods. So that's what they mean, is that the test data set is more complex than the training dataset. So, for example, when we saw the concatenation examples, there were questions with 2 words or 3 words. So that's the training set. And when they see the test set, it's about having words which are four, like number of words with 4, 5, 6 to 12. So they are more complex than the training set. So chain of thought doesn't perform well in that scenario. So that's why they came up with this strategy. Okay, so yeah, that's the key point here. And so least to most prompting have 2 types of prompts. One is two types of prompts because they have 2 steps. One is the problem reduction. So what they do is, so they have a question, okay, it's a new question, and they give examples on how question are reduced. So they will have like multiple samples where there's a question and the answer is sub questions. Okay, so it will show like how it should reduce the questions. Now when you give a new question, it's going to reduce in this way. So it takes Amy 4 minutes to climb to the top of a slide. It takes 1 minute to slide down. The water slides closes in 15 minutes. How many times she slides before it closes? So now to solve how many times she slides before it closes, we need to first solve how long does each slide trip takes. Now you take this question and then concatenate it with this question. Okay, so that's the sub question. So the first step deals with the problem reduction. The second step deals with answering those questions, sub questions. So now you have this new question. The language model is gonna give you the answer for it. Now you take these 2 things and concatenate to the original question and give you, this one is the new sub question, and language model is gonna give you the final answer. Okay, so that's the overall system. So now let's see like how it is applied to these 3 tasks. So one is symbolic manipulation, is nothing but the concatenation of the last letters. So the experiment setup is, so in this case, because we know like if the question is of 3 words, the sub problem will be 2 words, and then you move on to 3 words, right? So there is no need to have a reduction problem. Like we don't need a sub question to be produced by language model. It's just there. So they just use the answering the step 2. Okay, so this experimental setup is there are only 2 demonstration examples, and each demonstration contains at most 3 words. So this is how the step 2 looks like. So in chain of thought prompting, you have these 2 examples plus a new question and language model to answer the question. Okay, and they are not related. But in this they are related, because this is a simple one, this is a complex question, and they are related. Okay. So that's what they're explaining here. So standard prompting and chain of thought prompting are used as baselines. The context of standard prompting is simply the input output. We already saw how all 3 prompting works. So this is the result. This is because the test set has questions with 4 or more words. So we see here that standard prompting doesn't work at all. Change of thought works, but is gonna reduce fastly as the number of words increases, and this perform the best. That's what they are claiming. Yeah, they also discuss about some errors, like what all errors GPT-3 produces. So we find that only very few of them are due to incorrect last letters, or most of them are concatenation errors like dropping or adding a letter. So most of them are that. So next data set is compositional generalization. So let's see how it looks. So they are using a data set called SCAN. These are the samples from the SCAN dataset. So for example, the input is look twice after jump. There should be an action sequence like jump, look. So it's look twice after jump. So that's how it should produce. So to do that, so why they chose it, the action sequences in the training set, about 80% of the full set over something are significantly shorter than the action sequence in the testing set. This is how the experiment setup looks like. For the step 1, they use 8 examples, so it shows how it is reduced, plus one new question, and you get sub questions, and then you use these sub questions with 14 examples to get the final answer. So I can show you how this looks. It should be in appendix B. I think so, it is in appendix B. Let's go there. Okay, this is standard. Okay, so this is how it looks for the command. So one to reduce commands into sequence components, and one to map the components to actions. So this is the first one. These are like I think, yeah. So first one is like 14 examples, and next one is 8 examples. You can look through it more about it to know more about it. Okay, so let's go to the result of it. So again, if you see here, the standard prompting doesn't work, chain of thought doesn't work much, and Leachman actually gives a very good result, which is actually it's a huge difference, right? Again, there are some errors. They are like the model is sometimes confused between twice and thrice, and it also interprets after as and. So there are some errors which they documented. The third data set is numerical reasoning. So it's the question like we get in some standard exams. There's some percentages, and then how many percent of people are not in 40 to 49. So this is the reduction, how they get sub questions, how many percent of people are between this, and then they use this to answer the sub problems in this. Okay, so all of the methods are 3 shots, and the way the answer, and if you see the results, 0 shot means we don't have any examples. Standard prompting, we have 3 examples. Chain of thought, we still have 3 examples with some explanations, and in this one it is the examples are related. They are like sub questions answered, and this is how it looks. So overall, what they say is for multi-step reasoning task, and if we have test sets which are more complex than the training set, this strategy may work. And yeah, so that's all about this paper. You can go through the appendix. They have a lot of details about the experiments, and yeah, thank you.